Hello and welcome to you wherever it is you are joining us from today. This is a beautiful Wednesday afternoon in September, and you are at Industry Tech Days 2020. I am Kate Smith. I'm the editor-in-chief of All About Circuits, and hopefully you are here to join this live session from Orion fans. You're in the right spot if you are here to talk about cooling solution trends for harsh environment applications. So a lot of really interesting things going on in this session today. We'll be talking about AC fans, DC fans, accessories such as specialty filters. And these are things that are designed to function in harsh environments. And we're going to get into the, forgive the kind of pun for the harsh environments, but the nitty gritty, if you will, of protecting against environmental issues such as dust, moisture, salt fog, salt spray, temperature changes, humidity, the works. And we're going to delve into some of the details here about how these devices are increasingly capable of more and more, and how OEMs are actually taking advantage of that to allow just better functionalities for in terms of just efficiencies and decreasing cost of ownership. Some really interesting, perhaps unexpected ways to use these benefits. So here today with me, we have two esteemed gentlemen. I am pleased to be joined today by two experts from Orion fans. We have David Luna, who is an industrial engineer by training and the VP of Sales and Marketing for Orion fans by trade. He brings 36 years of experience, so be sure to ask him lots of questions and take advantage of that. We also have Ray Faries, who is the technical product manager for Orion fans, and he brings a further 35 years of experience and across distribution sales, manufacturing engineering, technical sales, and product management. So really good team here. Before I let them say hello, I'm going to get some of this stuff out of the way. If you look at the bottom of your screen, you will see a Q&A widget on your On24 interface. This is how you can submit questions to David and Ray. So keep that in mind as you're listening through the presentation today, and be sure to put anything that comes to mind in that Q&A box, and we'll get to that at the end of the session. This session will be available on demand after we're done recording. It takes about usually an hour, but you'll be able to enjoy this anytime on demand after that. I'm also going to direct you to the Orion fans booth page here at Industry Tech Days, where in particular, I want to draw your attention to the live chat function, which is a really cool option, so that if you miss your chance, if you're watching this on demand and you really wish that you had had a chance to ask David and Ray some questions, that live chat box is going to be your best friend. So stick around, because at the end of this session, we're going to announce a winner of our giveaway. I think that's my checklist. I think we're actually good to go. So thank you so much, David and Ray, for joining me here today.
Yeah, thank you very much.
Well, all right, let's hop right to it. We, of course, are going to bring it back down to the designer level. So what are the general challenges that designers that you come across at Orion fans face when they're dealing with thermal issues?
Well, the biggest one in this day and age is we're seeing cabinet densities are getting, the density of cabinets is so tough, causing so much heat problems. That causes airflow restrictions. Oftentimes they didn't realize that, oh, we're going to have to cool this thing till after the fact. So then you got to find a space to put the fan. You got to know if your fan's going to fail or not, or has it failed? It's a piece of delicate electronic equipment. Will it fail eventually? Yeah, eventually it's going to fail. A lot of them slow down over time. Most of the time they just quit working. They just stop when the fan fails. But that's usually several years down the line unless something dramatic has happened. Because of that, we sometimes need to monitor those fans to make sure that they are actually functioning. We can do that. Harsh environments bring in lots of additional challenges to the fan world and to the electronics world in general.
Yeah, for sure. And that's obviously the core concept here today.
Yeah.
Right. And that picture there showing a open frame MRI or CT machine, you can see all the fans used there. They're typically an all metal type, but you can just imagine all the harsh environment things that can happen with those, with not even high temperatures, because these things do heat up if you've ever been in an MRI machine. But there's also vibration and shock and different things like that. But you can see some very large fans being used there, and some that are encapsulated or around metal enclosure, but then an open frame one at the top. So a lot of these thermal problems can come involved in something like this.
Yeah, no joke. That's a pretty heavy-duty example you have there. It takes a minute to sort of understand what your eyes seeing in this picture, for sure. So that's actually a really great segue. And I kind of gave a little bit of a spoiler in the intro here, but can you talk to us about what those harsh environmental conditions are? What are the occasions in which they pop up? What are we up against? And how can cooling solutions address them?
Yeah, the main one that we see in most applications is water. Water spray, water jets, submersion even. We never suggest you submerge them, but submersion, salt fog. Anybody on the coast or anybody doing anything outdoor for the telecom world has to allow for salt fog. Salt fog is not just, it's called a fog, but actually it's a mist that they sprays in there. Salt water is very viscous, and it's very conductive, and it's very corrosive. That is a nasty animal to deal with. Corrosive agents in the atmosphere. Right these days, the one we're seeing a lot of is ozone. People are actually pumping ozone through the fans for disinfecting purposes. Apparently, ozone is a very good disinfectant, not only for water but for the air, for whatever any surfaces. That's kind of got big. Ozone is very corrosive. People sometimes don't understand that ozone is hard on things. The extreme temperatures that you can see. Again, fans are delicate instruments, so they're not real happy outside of some standard temperature ranges. People say, "Oh, I need to work to minus 40." Why do you want a fan running at minus 40? I have had that occasion where they had to have a fan because it was on what's called the night sun, and when that light came on, the fan had to be on instantaneously, regardless of the outside temperature. It actually was mounted on a helicopter, so a helicopter at altitude in the mountains is very, very cold, and that fan had to be able to come on and be running as soon as that light came on, or the electronics went away. So we actually had to go find a fix for that, because minus 40 chemicals start changing properties. That gets very, very difficult. Dust, dirt, sand, those kind of things. Those are very damaging to fans. Electronics in there just don't like that stuff, and they can actually clog things up. We can't stop it from clogging up, but we can stop it from affecting electronics. Shock and vibration, G-forces, constant G-forces. Fans do not like constant G-forces, and they're not a real big fan of impact G-forces. A fan is actually designed to be able to drop from about 24 inches onto a piece of wood. That's pretty much the standard where it has to work. If a fan in our warehouse is dropped off a table onto the concrete or what have you, it goes straight in the trash. We don't try to do anything with it because it can dislodge the bearings, and you can't tell, and it may not be an instant failure, but it can cause long-term reliability issues. So if we have unbalanced, we just make them go away. I say it's just not worth the issue. And I tell our customers, everybody thinks, it's a pretty rugged piece of gear. Realistically, it's not. It's actually a very sensitive piece of gear. The bearings are sensitive, pretty much in anything in the world.
Not just that he was mentioning, obviously with the salt fog and things like that, but I mean, we do discuss this as a harsh environment problem, but that dropping of product with the shock on there, like he said, we can tell when a product comes in for corrective action or for any kind of analysis. We can tell when the fan's been dropped. I mean, it's pretty clear and evident typically, because they are very, like Ray said, very very, delicate, piece of equipment. Even though they're just a fan, they really are delicate. So we have to be able to give these products the certain things, and we'll talk about those later and a little bit about some of the things we can provide to meet those challenges for these harsh environment and these extreme conditions.
Mm-hmm. And I see that you guys have already pulled up this next conversation about what those applications really look like.
Yeah, the application, it talks about extreme temperature, minus 40 to plus 125. Fans, heat is the enemy of everything, including the fan. We do not make a fan that'll operate at 125 degrees C. Not for very long. They will. They just won't last very long. The automotive world needs some of that stuff. 125 C, there's no human beings at 125 C, obviously. And at minus 40, they're not moving very fast. So, but it does require an automotive. HVAC, telecom, they see some of the extremes, typically on the lower end, not so much on the high end. Military, marine, machinery, wind power stuff, you will see some of the higher end temperatures up there. I think our highest rated fan right now is 100 degrees C, and that's an AC fan. The problem on the DC world is you can't get there because of the components internally. Most of them are commercial grade components rated to 80 C. We rate the fans to 70 C because we have an internal heat rise in the motor, because the fan doesn't actually cool anything. It just moves air. I say it does. It's not producing any cooling at all. It produces a cooling effect. Mm-hmm. Refrigeration panels, process control. I mean, a lot of panel shops put harsh environment fans in there because we never know where they're going to be located. We have one that's located inside a container that's hooked on the back of a tractor trailer rig. So, there's lots of ugly stuff going on out there. Chemical protection, the food and beverage industry is big time in that. Boats, anything marine, of course, where you have salt water, salt fog, telecom stuff. We are one of the few companies, we actually do have fans that are GR 487 rated, which is the Belcore telecom spec, which is a very, very difficult test to pass. That's 2 weeks running in a salt fog in a salt fog environment. We can't do that with all of our fans, but we can do it with many of them. If you want the GR 487, you have to kind of specifically ask for it. We can't do anything. Currently, we can't do anything AC or anything less than 38 millimeters thick. So our main focus on that right now is our 120 by 38 millimeter fan, which is a very popular in the telecom world for that exactly. Our regular salt fog product, which is also an encapsulated product, it's a very good product. It's made for salt fog. It's just not made to be in that environment for, let's say, the salt fog test cabinet runs for 2 weeks and actually up to 30 days. The regular salt fog is 2 days to 2 to 5 days in a salt fog cabinet. We make a wide variety of fans that'll do regular salt fog, which for most of the world is more than enough. The particulates we talk about, dust, sand. One of our big wins that we had a customer who was building car washes in Saudi Arabia. So not only is it hot, but it's sandy, dusty, and there's a lot of chemicals in a car wash. A lot of stuff, the soaps and stuff, that are all corrosive. And they were having failures. They were having consistent failures. We built them an IP55 rated fan, which is all they needed, put it in. And as far as I know, to this date, they have not had another failure since we went to the IP55 rated fan, which wow. IP50, we'll talk a little bit about the IP ratings in a little bit. Mechanical harsh environments, people sticking things in fans. You didn't think about it, but people stick things. If somebody sees a hole, they start sticking pencils and fingers and those kind of things in there. Fans don't like that. Fans don't like that at all. And then you have the vibrations and the shaking. Most of the time, vibration's not an issue. Real high impacts is the issue. So we're pretty good in products for a wide range of applications. One of the things we do is a bunch of pond pumps where they're putting like a fountains in ponds, or they're doing aeration in ponds. So you have a pump next to that. Well, that pump's subject to a lot of outdoor external forces against it, which is not just the water that may be, the chemicals if it happens to be treated water, or animals calling into it. So that's actually a pretty good business for us. We sell a lot of stuff into that world, that in the hot tub world. We actually sell fans that goes into the bases on the portable hot tubs. Again, a very kind of an ugly environment because chlorine is nasty.
Yeah, I think he was talking about earlier about that salt fog and mist. I think our recent edition of IP68 fans, actually, Ray, we did some testing on those just to see if they'd passed a salt fog mist test, not really a GR487 test, but just to see. And I think if I remember correctly, we ran those for about a week, and they passed with flying colors. So, of course, that's a very intense encapsulated type product, but it wasn't, let's say, geared to salt fog, but it definitely passed the requirement.
Yeah, we sent them out. We actually had them run for 2 weeks, and they came back and they worked fine, but they haven't been submitted for the GR487 testing. Let's kind of go that way. That we have not submitted them for the official anything other than the 1238s for the official GR487 test.
Sounds like a pretty high bar, but obviously for good reason. A lot of these applications that you've named, my assumption is that they're not putting a fan there for their health, or I guess not for looks at least. It's there to serve a purpose, and it needs to be reliable, right?
Right. Yeah, fans are not the prettiest things in the world to have to hang on the side of your equipment.
Some of these are lovely. I don't know what you're talking about.
Yeah.
But so far, we've taken the time to talk about the situations that engineers might find themselves in when they're reaching for a fan. What defines a harsh environment, what applications those particular challenges pop up in. How about we shift gears and we talk a little bit about the types of fans that you guys can specify that will address the harsh environment applications that you've just explained to us.
Okay. We have AC and DC fans. We can make almost any of our fans to an IP55 rating, almost without exception. We can make those to an IP55 rating. Which is water jets in all directions. That's all that most people need. A lot of people, we have people asking for IP68, and I ask them, why is your fan going to be underwater? One of my favorite deals about that, a guy was building a controller for an LED for parking lot lights, and he wanted IP68. Well, this light's going to be 40 feet in the air. I said, if that light's underwater, we got way bigger problems than your fan not working. But unfortunately, I hate to say it, but people kind of get hung up on, I have to have IP68. Well, you might want IP68. And can we build it to IP68? A lot of them, yeah, but it costs money. And I hate to see people throw away money when you don't need to. If you're going to have to budget for that, and most engineers have a budget for their cooling, and IP68 is just more expensive because it is an encapsulated product. And we use our IP55 and we do IP54. Not sure why we do that when everything's a 55 anyway, but we do a vacuum paralleling coating. It's almost invisible. It's very low cost. Does it cost more? Yeah, than a standard fan, but it's not outrageous. Once you get to the encapsulated stuff, it gets a lot more expensive because if one fails, it has to go in the trash. There's no reworking it. So from a production standpoint, the last thing you do is you pot it and test it. And if there's a problem, then you have to go on with that.
I want to meet this guy, by the way, the one that is worried about an underwater rating for a second-story parking garage.
Yeah, he had a spec he was given, and that's sometimes you kind of have to think just a little bit about what are you really trying to do. IP55 is made for the rain. That's exactly 55 and 56. That's what it's made for. It's made for rain. And I'm hoping that they're not seeing more than rain on top of a 40-foot pole.
Well, like you said, they probably
you
have.
never know.
I'm not sure anyone's going to hunt down the guy like, why didn't these LEDs work when there were 2 stories of flooding?
Yeah.
Just covering his butt, I guess.
Yeah, LED lighting does generate a lot of heat, and they are oftentimes in harsh environments, because they're out. A lot of times they are outside. As more and more as LEDs have gotten cheaper and cheaper, and the high power have gotten cheaper and cheaper. David's got company. They've gotten cheaper and cheaper.
Yeah.
So then people, but they have to cool them off because they do generate a tremendous amount of heat. So
Of course, yeah.
yeah. Let's talk a little bit about the IP ratings and what those actually mean.
Yeah.
I got it.
Well, one too many.
Yeah. So, IP, international protection. The first number is the dust protection. No protection, smaller, no size of dust. So it just has to do with how big the dust particles are. And then the second character, which is the most important part for most people, because if you do the first one, or if you do the second one, you get the first one. Is kind of the way it works. Most of our fans are IP000. They're not protected against. The standard production fan is not protected against anything except sticking your fingers in there. You can't get your fingers in there to the electronics, so you're not going to get hurt from electricity or from any of that kind of thing. If you stick it into a running fan, yes, the blades will hurt your fingers. But it's not protected for any water. 65% non-condensing humidity is pretty much kind of the industry standard for that. We actually see some stuff up to 95%, but it has to be non-condensing, because once it condenses, then it becomes water instead of just a humidity. The second digit is the amount of moisture. I say we do some 20s, some IP20 stuff, which for small dust particles. Most of what we do is IP55, and again, that's a pretty good dust protection and water jets in all directions. And then you go to 56, which is a little stronger water jets, and then you get up to the 67, and then 68 is kind of the next level of animal, which is immersion, indefinite immersion. The fan's not made to run underwater. They will run underwater, and we actually have a demo of a fish tank full of fans all running underwater. It's not what they're actually designed for. They were designed so that, okay, it happens to get dumped. We had 4 inches of rain here last night. Something gets dumped. Well, then it comes back out, it dries out, and it continues to work as it's supposed to. Typically if it's underwater, your electronics have other problems anyway, so it's probably not an issue that your fan stopped running. But the 68 allows us to, get it soaked underwater, dunked underwater, comes back up, goes right back to working, so you're not having to do a bunch of work on it in the field. Then you go to the 69, which is high temperature and high pressure water. And that's a pretty brutal test, because temperature, again, heat's the enemy. Then you go to 69K. That's our newest animal that we brought out. That is made for the washdown world. So it's high pressure, high temperature with chemicals in it. That is obviously an encapsulated fan. We have a line. How many have we got? About 4 or 5 part numbers or families now, David?
We got obviously 8 in the AC line and 10 in the DC line.
Yeah. So excuse me. Yeah. So that's for the washdown world, which is actually.
Oh, here we go.
Excuse me. I'm sorry. I thought I muted that.
Right.
Don't call it that. So that's even worse.
You could have told us anything. You could have said it was the president.
Yeah, that's crazy. It was probably the Nigerian prince, but you know how that goes. So anyhow, so that's kind of where the IP world is, and we fit in that. We have this stuff tested. We're not just making up numbers. We can test our IP55 product will actually work up considerably higher than 55. It'll work to 56. It just hasn't been qualified to that. If somebody really wants to do it, yeah, they can knock themselves out and go ahead and do that. It's very little difference between a 55 and a 56. It just has to mount with the amount of water. But it's kind of like water's water.
I was actually going to ask, I'm not sure if I know objectively what the difference between a water jet and a powerful water jet is. I'm not sure I'd know.
Yeah,
when
there is a
shift
spec for that. Yeah, there is an official spec for that. But again, once electronics get wet, they're either wet or they're not wet. How hard's it blowing up is kind of a whole nother story. It's not going to be hard enough to remove the coatings. So how about that?
Right. That's okay. We can work with that. And actually, as you're talking about the IP 9K, that's how you refer to it.
69K.
69K.
69K. Okay. So that one, obviously, we've been talking about a lot of different applications. I'm personally super curious about all the telecom stuff that you've mentioned here and there, but let's zero in on what my assumption is where that IP 69K really comes into play, which is when we're talking about food safety, right? Food and beverage applications where there's obviously some very tight regulations at play, I'm assuming, yeah?
Right. Yes. Tight regulations on food and safety. The government several years ago put a deal about that you have to be able to wash this stuff down. And, anything where they're packaging it, where they're storing it, where they're cleaning it, preparing it, whatever, they have to be able to wash it down. There's specifications of what they have to use for wash downs. That's what 69K was actually developed for cleaning garbage trucks, to go on stuff where they're cleaning garbage trucks. Garbage trucks have to be cleaned up because that's nasty. So the 69K was actually developed really for that. And then medical picked it up, and marine picked it up, and oil and gas guys picked it up, and wastewater guys picked it up. And then the food service industry picked it up, or the food preparation industry picked it up. And it's really, that's kind of that's the gorilla running it right now. That's where it is, because, of course, in this day and age, everybody is concerned about food safety. Yeah. You don't care if the trash truck is dirty. Nobody cares.
Hasn't occurred to me.
Driving the trash truck, but people care that their food is is in a deal that is clean and environment, and the fan that's in there has to be able to work, and it has to be able to work all the time and accept that stuff. And so that's why we came out and produced a 69K version of of several different of our fans. We can't do all of them, but we can do quite a few of them. People don't realize there's fans everywhere. I mean, well, engineers, our audience probably realizes there's fans everywhere, but but the normal Joe Blow on the street doesn't know that all the different equipment that actually has a fan in it. And with the density of electronics these days, more and more and more, we're seeing more and need more and more powerful fans, and more able to withstand the rigors of the environment.
And speaking of the rigors of the environment, we're just talking about some of these indoor facility management where you need to be able to wash things down so that they are up to code, I suppose you could say. We talked about some of these applications before, but can we zero in on the special fan requirements, particularly for outdoor applications? Yeah.
Outdoor has its own sort of separate set of issues. Obviously, the weather's the biggest stuff for outdoor. Weather and, depending on where you live and where it's going, whether you're going to have salt. Animal interference, and animal means humans too. If you have something on the ground with holes, kids stick sticks in things. Raccoons are real notorious for sticking their feet and sticking their little hands in everything that they can get around. You have to have some way to protect the fan from that stuff. Outdoor stuff, you may have a sealed cabinet or an almost sealed cabinet. Well, so the fan has to have a hole. It has to have a hole to bring the air in, and it has to have a hole to get the air out of. If you just put a fan inside a sealed cabinet, you've created a convection oven. It's not cooling anything. So you have to be able to get cool air in and hot air out. And we tell people, if you have any possibility to do it, blow cool air into your cabinet and exhaust the hot air out through the top of the cabinet. We say, let the cool air come in through the fan. But if you put a fan on your desktop to cool yourself off, you don't put it pointing away from you, pulling the air across you. You put it pointing towards you to cool it, to push the air onto you, to cool you off. The cabinet's the same way. The fan's designed to blow the air. Will it suck the air out? Of course. And do we have customers that do it all the time? And do we actually have a fan tray made to do that, to suck the hot air out? We don't recommend it because it's hard on the fan. The hot air coming through the fan reduces the life of the fan. A 10 degrees C increase in temperature coming through the fan is just about a 50% reduction in life expectancy. That's pretty significant. And so, if you're pressurizing your cabinet, you're also keeping other stuff from getting into your cabinet. If you're pumping air into that cabinet, and then you're now keeping bugs from flying into the cabinet, because any orifice, any hole in that cabinet has air coming out of it. And so it makes it much more difficult for foreign objects, albeit dust, water, or sticks or insects, to get into your cabinet. So if you're pressurizing your cabinet, and you're just going to be better off. That also allows you to filter your air as you're coming in. When you do that, you got to be able to, anything that's outside is going to get dust in it. It's bad enough in the house or in a building, but stuff outside is going to get dust in it. Customers' equipment may not like the dust. The fan that will deal with the dust, eventually you can put enough on there where you can actually damage the fan. In a standard environment, the fan doesn't really care. But if you got something that's outside, like we talked about earlier about the car wash, in Saudi Arabia, there's a lot, that's a lot of stuff in the air, and you got to be able to filter that stuff out. You got outdoor applications, you have kiosks, there's, and more and more, there's kiosks on every street corner. Well, they have a bunch of electronics in them, and they got to cool them off, and people are going to have access to them, unfortunately. Pump controllers. We talked about, I spoke earlier about the pumps, for like well pumps even, but mostly for like pool pumps or pond pumps, where they're aerating the air, or just for cosmetics or what have you. EV charging stations, obviously big time right now. Electric vehicles. So, everybody's on the bandwagon to build charging stations. And those are all, I won't say they're all, the vast majority of those are sitting outside somewhere. And when they're running, they do generate a lot of heat, so they got to be cooled off. Telecom enclosures, on every street corner, you see those big silver boxes, where all your twisted pair of cables are coming into. A lot of times, not all the time, but a lot of times they have to cool those off. There's other electronics in there. They have to cool that stuff off. Traffic light controls, those big silver boxes on the corners, those all have fans in them. And they're outside exposed to the weather. So it's really important to protect your fan, so that your fan can protect your gear.
And we also mentioned the transportation with the bus on the top. You and I mentioned the other day about that application you've worked on in the railway industry and braking systems and things like that. And, how critical situation or application can be with a fan based in that atmosphere or that application.
Where that fan's located, or one on a bus was actually inside the heating controls for the bus. So it was actually moving the hot air through the bus. The fan really didn't like that too much. And the problem with buses is that the 24 volts that they say the battery is not really 24 volts. It's somewhere over 26 until the alternator turns on, and then it's 28, 29, 30 volts. And fans tend to not like that. DC fans are, again, they're delicate. They have a fairly limited voltage range they want to work in. Our standard, we say, is plus or minus 10%. With our bus one, because they were heating the fan and they were running it at elevated voltages, again, they were having failures. So we wound them a fan to 28 volts and made the problem go away. So we made them a custom fan to fix their issue. And I'll say battery applications are tricky. And then you add it as to a harsh environment battery applications, it gets even trickier. I think the one we did is talking about a train. It actually hangs in the electronics hanging under the train, so that there's fan there. If you go to LA and ride any of the LA trains, we have fans hanging under all those trains, and our fans replaced another maker's fans because of the issues they were having. Because we could make them, we actually had to seal up all the electronics to keep the stuff out, because trains don't run in very pretty atmospheres a lot of the time. What's our next one?
I think we lost Kate.
We were talking about outdoor applications. We talked briefly about filtering, protecting the fan, because the fan itself can't do anything, because the fan's a great big hole inside of your cabinet. So you have to have a filter of some kind. We make 3 different versions of what we call our louvered filter fan guards. We make a one where the front snaps off. We make one where it's hinged, and we make one that slides up and down. Excuse me. Those are nice because they're IP54 rated. That filter itself is IP54 rated out of the box. It is a louvered, it's a fixed louver, so it's made to be in the rain. So rain comes down on it, it helps shed the rain. The standard media that's in there is replaceable or washable, and it gets us to an IP54 rating without worrying about what the fan is that's hanging behind there, because it keeps out most of the water. It's made to meet the NEMA 12, Type 12, and say up to IP54. The IP54 is with a slick surface to be mounted to. If it is a textured surface, there is a gasket, a neoprene gasket on the back side of them that's made into the guard. But if you have too much texture, you can break a seal so that you don't get a good seal around that. All of our louvered fan kits we make some specialty filters, high density filters, water repellent filters, which is even more than the 55 or more than 54, and our fire protection filter. The fire protection one, actually, if it gets too hot, it actually closes the cells off in the filter to stop flames from coming into your equipment. You know, if you have flames outside, I'm not sure that's a real problem, flames getting in, but there's some places that require that as part of their code. Except for the fire protection one, those are rewashable, reusable, so you can clean them up and reuse them, and they will fit. If you buy say a 254 millimeter one, it fits into our 254 millimeter, into our guard that's made for the 254 millimeter fan. So, and we have fans, we have them from 80 millimeters to fit 80 millimeters up to 280 millimeters currently. And I always like to say, this is, if you notice though, on the right side of this picture, it shows a cabinet. And it shows the cool air coming in at the bottom and the warm air, hot air going in at the top. That's the way air wants to flow. Air wants to flow, cool, rises, and that cool air is going to go in and blow that hot air out the top. That's what you're trying to accomplish right there. Adding filters, the biggest issue with adding these type filters is the airflow loss. And you're talking approximately 40%, depending on which filter and media and fan, you're talking approximately 40% airflow loss to go through the filter, because it has to be dense enough to let stuff in, but still let air in. But because of that, you have air pressure drop. We sell these where we mount the fans already to the guard, so all the customer has to do is walk up. They have to cut a hole in their cabinet, stick it in there, and screw it down. The smaller ones are actually snap in. They don't even have to be screwed in. They'll actually snap into a panel. But we can put almost any fan on a guard. Some fans will go on multiple different sizes of guards, but any 80 millimeter fan we have a LFG that we can mount the guard to, or that we can mount to it. 120 millimeter, same thing. We can, if we have one that fits the outside diameter, any of our fans can go there, whether they're IP rated or not. So, if the customer needs, IP54 is enough for them, then they can just buy an LFG and stick a standard fan on the back of it, and the filter is actually going to protect the fan at that point.
Right, but we typically can make any kit we want based on the requirements. So we can even use an IP68 if we wanted to. Doesn't mean the whole system is going to be IP68, but the fan will be protected more than a normal fan, let's say. And then these filters, normal filter and the louvered guards are only 8 ppi, which is a little bit of dust filtration. But on the high density ones, we can go to 45 ppi, and actually we can go all the way up to 80 ppi if we had to, depending on the requirement, which is kind of nice. But again, like you said, the airflow restrictions are pretty massive when you obviously are filtering, and people should understand that. But still gives you a good way to protect your equipment inside and out. So.
I think I've been having a couple of audio issues. Can you guys hear me now?
We can hear.
Okay, great. I had a couple questions in there, and since you guys didn't get to hear them, you can just assume they were brilliant and amazing questions.
I'm sure they were brilliant.
At the end, if there's time, I'll also officially take up some of your Q&A time, but I think we've got a pretty good queue of audience questions, so let's just assume that they were the best questions ever, and just leave it at that.
The one thing we haven't touched on is ATEX. We do have a limited, I'll say limited, I believe it's 6 different sizes. Is that right, David? 60, 80,
60 millimeter to 254, which hopefully we'll have that requirement by next month.
Yeah, they're ATEX Zone 2 certified, spark proof, basically. It's a full IP68 rating, along with the ATEX rating. These fans go on. These are actually all EC fans, so electronically commutated. The advantage there is you can have either more airflow or lower power with the EC fan. It also allowed us to do the ATEX certification on these. It is Zone 2. Many of our other fans and blowers will actually pass the ATEX certification test or the UL test, depending on which one you're after. We have customers that have taken our reverse impellers and have them explosion rated. We didn't do it. We weren't in a position where we wanted to do that. We supplied the customer all the data for them to go to UL with, and UL gave them the certification for explosion rating on a standard fan. Most fans, they have enough gap in there, and there's nothing in there that creates a spark. On the AC side, the DC side's a little bit different. I'm not sure you can actually get there on the DC side unless you went to an IP68 type fan, and because it is encapsulated, you might be able to get it through. But that's not something that we are currently chasing down. It's not something we're pursuing. There's not a huge call out for ATEX type fans, and most of them are in the AC world. I don't know if you don't know, the EC fans are actually an AC input fan, but inside the fan is a DC motor, a DC controller. It does all the voltage conversions internally. So, but the layout internally allowed it lent itself very good to doing the ATEX certifications. That just says it's not going to generate a spark is basically what that says, and there's nothing there to make it spark.
Well, there were a couple other questions in there in between that just kind of fell through the cracks, but we actually do have quite a large queue of questions. Can I just ask you guys, is there anything else in particular you wanted to make sure that you got a chance to, any other points that you wanted to make sure you made before we go into the Q&A section?
No, I think we're pretty good.
Okay.
I'll add one. I'll have to remind Ray. because I introduce products all the time because that's what we do around here, me and my marketing team. But we do have a 100 degree C DC fan series coming out, actually, from 60 millimeter up to 172. But they're all metal because, like Ray had mentioned, with DC, you normally don't see that with 100 degree because of what it can do, the electronics inside. But these are obviously encapsulated. They have metal frame, metal blade, which normally our DC fans have some kind of plastic in them, but these don't. And we're going to be introducing that series in the next couple of months. So that is 100 degrees C DC as well. So just an added.
As a technical sales guy, I like to not talk too much about stuff that I don't have in my hand yet.
So yeah, thank you for adding that. Let's dive into some Q&A. One quick public service announcement, or really service of one particular listener. I'm going to announce the winner of the giveaway for this session. Congratulations to Jennifer Taylor. So Jennifer, we will find you. Get
One of our favorite.
Oh yeah, we're good work, Jennifer. It's public service announcement. It's really just the Jennifer service. But yeah, we'll reach out to you. Please look out for some communications from our team, and we will get you the prize package. So, okay, trying to be cognizant of time here because we've got quite a few questions for you guys. Let's start with this audience member says, I interned at a distributor over the summer and learned that engineers get paid on what I think they called design registerable or something like that. Are these IP69K fans design registerable? Interesting question.
All of our products, we have a design registration program for our distribution network, and so yes, if the distributor does a design, they can register that design to protect them for that customer, for that specific customer.
All right. Okay, let's move right along. Could you recommend a certification for high ozone concentration, and they say about 50 parts per million, both for fans and filter media? They say this may have already been answered, but my internet isn't rain tolerant.
Yeah, we can't filter ozone. We can move the ozone. We don't have any way to filter the ozone. Our IP55 fans will withstand the ozone. For every application we've done so far, the IP55 withstands the ozone without a problem. Now, I don't know for sure how. I don't know what level ozone they're talking about, but we're doing it for a lot of guys. They're building growing and drying boxes for the medical marijuana industry. They use those because they use ozone to stop the plants from molding in there, and that's a fairly high ozone level, I believe. But yeah, we don't. Our IP55 fan takes care of that.
Nice, interesting. And speaking of other applications that we haven't yet touched on, I mean, you guys touched on a huge gamut of applications, but one eagle-eyed listener realized that one didn't come up. Is there a solution for avionics?
We sell into the avionics world. Not a ton, but we do. The problem is avionics wants special wires. They have to have special lead wires. They can't use PVC, which is a standard deal in there. We do make some. We have made fans with nylon wires for the avionics world. We don't certify anything for avionics, but they can be certified for the avionics stuff if we make them with the special wires. It just makes it's something that we have to do special to do that.
It really depends on the application too, because a lot of times they're asking for a G-force of some ridiculous amount, which we really can't adhere to a lot of times. But if it's in a normal situation, like say inside a cab of an airplane or something like that, and there's not a lot of large requirement for it, it doesn't have a mil spec or any kind of avionics type spec, then we've been able to match up a right fan or assembly for that application.
Yeah. But we do we have them in a lot of airplanes. But we kind of leave that up to the customer to do their certification if they need that.
Okay. All right, let's move right along to how do we determine which fan filter to use for a given application, and how does it affect the CFM?
Well, I've told more than one customer, I can't tell you what filter you need because I don't know what your application looks like exactly. And even when I do, I don't know where it's going to be, what it's going to be like. We can offer, we have 30 ppm to 80 ppm. How much do you need? And obviously, the denser your material, the more you're filtering out, the lower, the higher your loss is. Let's just say our regular, what we call our GRM, which is a grower retainer media, it's just a small snap-on plastic filter. It's probably 15 or 20% drop. You get up to the LFGs, you're talking about 40%. You do an LFG with a waterproof in there, you may be talking about 50 or 60% loss. Depends on the fan that goes on there a little bit, but it's kind of all over the board, and it's really, really application specific. And we can kind of say we think, but it's up to the end customer to make the final determination on that.
Mm-hmm. And maybe recommend that they just reach out and talk to you guys, huh?
Yeah, just give us a call. There's somebody here all the time. All
right. Does Orion have fans and fan filters that meet the telecom NEBS GR63 core requirements?
Not familiar with that requirement. One I really was familiar with was GR487 for the telecom world. So I'm not. If they reach out to that spec, we can certainly look at it. We build a lot of stuff into the telecom world, but we just have to look at it and see. They just have to reach out to us. Call us at the office and or send us an email and tell us what that spec actually is, and then we can go figure out if we already have something or if we can make something.
I've seen the NEBS requirement some on the filters section of things. So I know on the filter side, we've had some filters that at least meet the requirement. Now, to be rated at it, I think that's the question of if we're able to do something like that. But we'd have to look into that a little bit closer, like Ray said.
Mm-hmm. All right. Thanks for tackling that one. Let's move on to the next one. This person says, when you say that fans won't last long at 125 degrees, is the time of reference like a few hours or days? They're trying to understand what's expected of the fan here.
Well, at 125 degrees C, they're not going to last long at all. Because we have no fans rated to 125 C. Most of our fans are life rated at 40 degrees C. Most of them are 70,000 hours L10 at 40 degrees C. Kind of depends on the fan, but that's kind of the standard commercial fan. Say, and if again, as I said, if you if you increase the temperature 10 degrees C, you're just about cutting that life in half. So, at 125 C, first of all, a DC fan is probably not going to work more than a minute or two, just because the electronics are going to give up. The AC fan will work for a little while, but it's not going to be real long because the insulation is going to break down. And we didn't talk about that, but DC fans are all Class A insulation. Also, that's part of the for the lower ratings. Most Class B fans are Class B, or AC fans are Class B rated insulation, and we even do some that are Class F rated, which that's 130 degrees C internal temperatures and 155 degrees C internal temperatures. But you have to allow for the heat rise inside the motor also. So, would an AC fan last for a little while at 125 C? Yeah, but is it going to be days or weeks? Yeah, probably. It's not, we just don't test anything up there because we're not rating anything up there, and you're so far outside the realms of our norms. 125 C is hot.
Fair enough. Are there specific options that are available for harsh environment fans?
Yeah, on our DC fans, we can do most any options. By most any, alarm, tachometer, PWM. It depends on the size of the fan, whether we could put one or all on there. All of our alarms and our tachs are open collector. It just adds a third wire out there. The PWM is the customer input, and it varies a little bit by fan what the control does in this. But like I say, all of the DC fans, we can do that. They're harsh environment. AC fans, there's not very many options for external tachometers, that kind of thing. We have a few of them, but that's really a really limited window.
Mm-hmm. Understood. I think we do have a couple of other questions here that we wanted to get to really quickly. We'll keep an eye on the time. An interesting one for you. Which fans are protected from smoke or heated air?
Well, smoke is really, depends on what's in the smoke. So that's kind of an open-ended question we talk about. And heated air, how heated air are we talking about? The fan rating, the temperature is if the fan is rated to 70 degrees C or 80 degrees C, that's as high as the fan is rated to go through that fan without causing short-term irreparable damage. Smoke, and you never know. We're just talking about wood smoke. It's probably not going to do any damage to the fan, but anything that's going to have particulate in it, you're probably going to have to go to an IP55 type fan to protect the electronics from that. Because anything that's going to have particles in it that might deposit on your electronics.
All right. David, anything you wanted to add on that one?
Well, I was just thinking, because Ray said before, we really don't want to be sucking in hot air. We want to be blowing it out, or keeping it out of some sort. So it just really depends on the heated air that they're talking about. We really want to be able to blow that out instead of suck it into the equipment or something like that from being the outside or something like that. So, because it can cause havoc to the fan, or for sure the life expectancy.
Absolutely. All right. I think we have time for one more under the wire here. Can single-phase AC fan speed be effectively controlled over a range, or is it functionally determined by line frequency? It's a pretty good ending question.
The frequency, the line frequency will change it. We always say if you're going to control an AC fan, use a thyristor of some type to control. You have to control the voltage on an AC fan, and that controlling the voltage as you go up and down in voltage, the fan's going to get faster and slower. It's fairly linear as you come up and down on the voltages. You want something that's fairly clean. That's why we say use a triac type controller, similar to a really good dimmer. If you have a dimmer that buzzes, it's not a really good dimmer. It's probably not got a triac in it, but a good triac type controller, you can control an AC fan across the whole range of the fan. And a 120 volt fan, they're only rated to start at about 80 volts. Actually, most of them will start considerably less than that. You just have to have enough energy to get the blade started. That's the biggest thing. You have to. That's the hardest part is to get the blade started. And once you achieve that, we say if you start a fan and you're going to run it at a lower speed, run it to full speed and lower it back down. That allows the fan to come up to its operating like it wants to without working too hard. Otherwise, it has to work really hard to get everything started up if you start at a real low voltage.
Mm-hmm.
And we say on frequency, 50 hertz versus 60 hertz. Almost all fans run faster at 60 hertz than they do at 50 hertz. But that is not 100% true. So we do not recommend doing that because you don't know for sure what you're going to get. There's some torque issues in there that causes the fan to actually run slower at 60 hertz than it does 50 hertz, especially on the really low ends of speeds.
Mm-hmm.
I just found that out after 30-something years in this business.
And everyone here just learned it as well. I feel like this is energy at its finest. And actually, I do apologize. That's the end of our time today. Sadly, I won't get to my brilliant questions. I'll talk to you about it later. It's fine. But Thank you guys so much for being here, everyone in the audience. Some really amazing questions. If you have additional questions, I'm going to remind you to pop by the booth and make sure that you use that live chat function. And check out all the really cool content that Orion Fans has on that page too. Thank you to Jennifer Taylor. We'll hunt you down. And just the biggest thanks in the world to our two speakers, David and Ray. Really cool session, guys. Thanks for your time and insights.
Thank you very much.
Appreciate it very much.
Check out the rest of Industry Tech Days if you get a minute, and don't forget to use that live chat on the Orion Fans booth. Have a great day, everybody.
Thank you. Bye.
Thanks.